Hello, welcome to the AWS Virtual Workshop series on deep dive into designing a successful migration journey. This workshop is a series of 6 different episodes. In episode number 1, we will talk about the migration journey, which is end-to-end migrations, and the decisions we need to make during the migration process. In episode number 2, we will cover how to build a business case and how to align business and technology stakeholders and make sound migration planning decisions. In the episode number 3, we will cover migration readiness assessment, which is a workshop. In episode number 4, we will cover the 3 phases of migration, which is assess, mobilize, and migrate. And we will go deeper into the mobilize phase. In episode number 5, we will talk about portfolio assessment and how to create a well-oiled migration machine. In episode number 6, we will talk about defining an operating model before, during, and after the migrations. So let's get started with episode 1 on journey through the center of migrations. My name is Kiran Kuppa. I'm a migrations and modernization solutions architect with AWS. So over the past few years, I had an opportunity to be part of many large-scale migrations with some of the largest and the most recognizable organizations on the planet. Working through these migrations, I have experienced processes that leads to a successful and accelerated migration versus the ones that create blockers. In this session, let's take a walk through what a migration journey should look like. And I will also take this opportunity to share with you some pro tips that will hopefully help you accelerate your migration journey and reduce the risk. So here is what our migration journey should look like or will look like. As we start, we will take a look at some of the most common migration drivers, and then we will walk through the activities to perform to assess our environment that we will be migrating. And once we are ready to mobilize our plans, we will walk through 2 different tracks, and this is where we will be spending a lot of time today. Then we will go through the most common migration paths that our customers take, and finally, walk through some important post-migration activities. This journey can be consistently applied to the organizations that are migrating to the cloud for the very first time, and also to the customers who are operating on the cloud for many years now. This also applies to a single application or a single workload or a data center exit scenario as well. Since migrations are long-term commitments and need constant steering to bring up multiple activities together, in this presentation, we will learn how to orchestrate each step of the migration to essentially help you maximize the velocity and reduce the risk. So let's take a quick look at the migration drivers. As a business, you have identified a need to migrate into the cloud. This may arise from many different factors, such as like structural changes to the business, where you have mergers and acquisitions, maybe new partnerships, or you saw a need for centralization of a heavily decentralized business unit. Or recently, you had a change in executive leadership. For some customers, it's all about cost reduction or even real estate consolidation and modernization. From the infrastructure point of view, there may be scenarios where you're out of capacity inside your data centers. There may be a disaster recovery requirement, or maybe you're launching new products and new services, or maybe there are end of life for hardware and software and scenarios like that. And for many customers, it's a modernization need, like implementing new data analytics workloads or HPC workloads that require like specialized and customized hardware setup for performance. I've worked with many customers in different business verticals, both large and small scale, from auto to financial services, to tech services, to healthcare. And what I've seen is that few migrations never took off due to analysis paralysis at many different stages of the organization. And few others essentially doubled or even tripled the time to migrate due to misalignment in the objectives. So as a business, understanding the impending event and knowing why we are migrating and being in alignment with that idea is a critical thing to migration success. So as an enterprise, you identified the workload that makes the most sense to migrate, both in terms of financial and business benefits. Some of these migrations that I often see are a single application or a single workload migrations, something like a customer-facing application. It could be a data and analytics application, a .NET-based app, a Java-based app, or a middleware, and so on. Many migrations that I come across are actually data center exits, full data center exits that include like multiple geographically dispersed data centers. And all the migration conversations are usually incomplete without touching the sensitive conversations, such as homegrown applications with no forward-looking path, or even legacy non-x86 environments such as mainframes. The journey we're going to take today can be applied to all the above scenarios with some tweaks as we go. So what I've learned from these scenarios is that there are best practices available for virtually all types of workloads. You don't have to reinvent the wheel. We have industry-proven frameworks and methodologies that we can help you with, and we can bring you that prescriptive guidance as we go through the journey. And also, there are many partner tools and platforms available out there that essentially complement the rich set of tools that AWS provides. Since with migrations, there are many choices to have and decisions to make. If you've not heard of this term already, let me introduce to you a concept of a one-way door and a two-way door. One-way door is a decision which would be very costly to reverse if you find out it's wrong. So this deserves a very careful consideration. On the other side, the two-way door is where you can make quick decisions because you can simply turn around and leave the room if you don't like what's on the other side. Now, applying this same concept to the migration journey, there are technical decisions that have to be made along the way where some are easily reversible, but others will be very costly when you switch your decision, especially in terms of time and resources. So also remember, with cloud adoption, there are many things that are incremental as well. We want to start small and expand, but have a robust mechanism that can essentially scale. So the idea here is to build foundations the right and the robust way and identify what is important now and what can be built eventually. So when you enter the planning and assessment phase of your migration journey, there are many things to consider. So based on what I've seen with many customers or many migrations, both large and small scale, are that these three important activities that you don't want to miss out on. First is the dependency mapping. Most customers start with an existing inventory of machines or applications or even a CMDB. They are usually directionally correct, but they do not provide you with the turn-by-turn navigation details that you really need. This is an important step to reduce risk of breaking the applications during the process of migration, and also will help you with migration wave planning, which we will talk about a little later down the slides. So there are many tools available in the market today that will provide you with server to server, application to application, application to database dependency maps with very rich details. So what we've seen is that customers running the dependency mapping tools during the assessment are able to essentially plan and execute migrations way more efficiently, saving days to weeks, and more importantly, reduce the risk. The second is the cost analysis, which is also part of building a business case. And we will cover these in the other episodes of the series as well. So the total cost of ownership, TCO, is more than just server and storage costs. If you're moving just one application, TCO might not make a whole lot of sense. But when you migrate an entire data center, the TCO analysis or cost analysis is a needed exercise. I've seen customers and consulting partners run through AWS calculators for server and storage costs, and many times skip or even forget things like bring your own licenses versus license included model for operating systems, for databases, enterprise agreements, managed service contracts, and so on. Again, these will essentially have a significant impact on the total cost and also will influence your design decisions and approach based on how you decide to support it. And finally, we need to ask ourselves if we are ready for migration in terms of business, people, governance, platform, security, and operations. At AWS, we refer to these elements as the pillars of cloud adoption framework, which essentially is a published white paper that you can download and read. So you can use this as a measuring stick in a self-service manner. And AWS can also help you run this MRA or Migration Readiness Assessment Workshop, which will help you assess your readiness for a large-scale migration and digital transformation. So again, this is a really highly recommended exercise, even if you're actively using AWS platform today. So every time we run this with our customers, we always uncover many gaps, and this gives us an opportunity to dive deeper into them in later stages of the migration journey. So let's begin with the discovery process. So once you decide to migrate your workloads, it is important that you understand what you're dealing with in terms of applications and its dependencies. This step is very important to reduce risk of breaking applications during the process of migration. Again, there are many tools available out there in the market that will help you provide with a rich set of details such as server to server dependency mapping, application to database dependency mapping, application to application dependencies, storage dependencies, legacy system dependencies, network connectivity dependencies, and API dependencies. Picking a wrong tool in this scenario will essentially cause you additional burden of manual discovery during the later phases. Or it could also result in deploying maybe second tool or a third tool if you think the data with the first tool was not good enough. So how do we pick this discovery tool? That's a good question, right? So how many tools, out of there are many tools to choose from, you need to find the right tool that fits your needs. And it really depends on the workload or the type of workload that you're trying to discover. The first consideration is agent-based tool versus an agentless tool, where agent-based tool, you install an agent on every individual machine. An agentless tool essentially looks through your network and identifies the data. Now, it is also important that this tool has the ability to discover the storage systems, such as shared storage, network connected storage, and etc. Can this tool discover databases, or even more specifically, the database type, the database version, and the licensing as well? So you need to make sure that the tool can essentially perform licensing discovery at operating system layer, application layer, and even database layers. So the question is, can it actually discover containerized applications? And how about legacy systems such as mainframes, or even less common operating systems like AIX and Solaris? So once it discovers the data, it's also important to know where the information is stored and making sure that your InfoSec team is okay to essentially share this information with external vendors. So to help you decide, we recently launched this prescriptive guidance page to help you make those decisions very easily. Now, before building foundations, we need to build a team with the right composition of skills and needs. In an organization, there are many stakeholders that build and manage an environment. Depending on your organizational layout, this may be one team or many different teams. Remember that everyone is a stakeholder in this game. If you don't have the needed representation from every team, you will end up with incomplete architecture, and this will lead to unwanted patchwork at the later stages. I've seen many times, especially in large-scale migrations, where the roles and responsibilities are fairly isolated, and that essentially leads to multiple iterations of your architectures. So as a best practice, we recommend that you build a team as a cloud team or a cloud center of excellence team. And if you want to know more about how to build this team, we have a detailed published white paper that you might find useful. This will also allow you to be more agile with your setup. This will allow you to be more agile with setup and also help reduce blockers and reduce friction. So now that we have done our homework on how to plan migrations, let's mobilize ourselves and put this plan into action. We see this as two separate tracks, very similar to moving into a new data center. In track one, we need to address the basic infrastructure layout first that will essentially host your applications. And in track two, we need to build a plan for applications, like how to migrate, what approach to take, what tools to use, and we can do this on application by application basis. So let's go deeper into the infrastructure setup. So let's start with this question: do we have a landing zone or the AWS infrastructure setup that is needed to host your applications? If the answer is no, then we essentially are going to go and build one. But if the answer is yes, then the follow-up question is my landing zone robust enough to scale and handle additional workloads? This question is relevant both for a data center exit as well as a single application migration. And this essentially will lead to infrastructure design and scaling conversations across multiple different areas, such as governance, networking, security, partner solutions, SaaS connectivity options, and operations model and automation. So let's focus on these areas and dive a little more deeper. And at this stage, it is recommended that you conduct a well-architected review. If you have an existing setup, then conducting this review to make sure that you're following AWS best practices. And every time we run this, we always identify small or big gaps that can essentially be improved and otherwise would have been blockers in the migration. Additionally, conducting a multi-account structure review is also important, where you're essentially planning out AWS accounts with connectivity and isolation between them, which is very important. Since this is a platform for all future workloads as well, it is important to take time and get this right as much as possible. You don't want to be in a position where you just completed a full migration and then realized that the account structure is either too flat or it does not fit or accommodate all your business units. And you're now forced into modifications the very next year. And this essentially also increases your technical debt. This may well take 2 to 3 weeks to organize meetings with your internal stakeholders and get buy-ins, but this exercise is well worth spending time on. Similarly, networking is a very important component. Reviewing your networking architecture for things like routing, traffic flows, network security, device placement, transit gateways, traffic filtering in both east-west and north-south direction patterns, and so on. Finally, it goes without saying, you always want to review your security controls and always aim for security automation as much as you can. Now, most of the times, these discussions have to go much deeper. And with any technology component, the devil is always in the details. You can run them as an individual or combined workshops to come up with a finalized architecture for the landing zone. And again, these epics can be further broken down into sprints to simplify your conversations. So in terms of governance, the first task is to usually answering the question of how many accounts do I need or how many regions do I need? What should I use? What should I not use? Where do I consolidate and where do I isolate? One of the most common workloads, for example, that I see with our customers is nowadays is the data lake workloads, where you have multiple data generators and you have multiple data consumers. And this has a huge bearing on how you're essentially provisioning your accounts and your governance model in terms of cost and security. Similarly, you might have other workloads that essentially dictate the account structure. In a data center exit scenario, each business unit has a different need, right? It could be a combination or a separation of dev, test, and prod environments. And as the number of accounts grow and the AWS services also grow, how do we manage them and keep them consistent across the organization? And this is where services like AWS Control Tower will help you simplify things. So even in the cloud, you need to think about disaster recovery and high availability for your business critical applications. Again, this is a simple design principle, but very important. And there are probably more parameters based on your business needs and support teams, the way that it is structured, which will also influence your designs. In terms of networking, which is again a second layer of the foundation, not getting this right means you will end up spending more time fixing and moving workloads at a later point. Take time to plan your network connectivity, the IP planning, the routing, the multi-region routing, transit gateway routing, and the network security tooling for filtering and inspection and so on. Security is applied usually at multiple different layers, and it's an ongoing process, and the end goal should be security automation. The best process here would be to essentially stick to a framework such as NIST that will help you identify, protect, detect, automate, respond, and recover and the environments. And again, most organizations today are moving to a SaaS-based model. So if you have a need for a B2B or a B2C connectivity options, then you need to plan it well ahead of time. Operations are seen as an essential and ongoing part of the maintenance. You need to start choosing right tools and modify the processes and responsibilities to fit your cloud model. And finally, automate and automate and automate with whatever tools that you can. You may already have many different tools that you're already leveraging, and you may actually use various different partner tools in the mix as well to essentially build the automated cloud infrastructure. Now, again, there are many partner solutions in the mix that you can bring in as well. And again, the idea here is the output would be a landing zone that is ready to accept your workloads. So the first decision that has to be made in building a governance model is a multi-account strategy. So when you start in the cloud, most customers start with a single AWS account, but very quickly that number of accounts grow and you need to decide on the account strategy or how many accounts do you need and what your boundaries would look like. The next thing that you need to decide is how many regions do you need and where your business users are located. Do you have any data sovereignty needs and business continuity model and so on. In terms of DR and HA, or disaster recovery and high availability, This is primarily governed by your application RTOs and RPOs and the backup mechanisms that you have to use, such as like file level backups or machine level backups or recovery tools that you use today. And the decision has to be made if AWS multi-availability zone model will suffice your requirements, or do you need to go spread across multiple different regions? And finally, given the dynamic and scalable nature of the cloud, you need to have a mechanism to manage the cost. And again, it could be setting up alerts or using budgeting tools or even partner tools for cost management. So these are some of the decisions that you have to make in terms of governance models. So you may ask the question, why do we need multiple accounts? So you essentially may have many teams that you can group workloads based on business purpose and its ownership. Accounts are usually the natural boundaries. So when you apply these distinct security controls, then essentially that will provide you with an isolation boundary in terms of security controls. Costs are incurred at an account level. So activity and costs can be identified within each account. And you can also deploy multiple accounts for different business processes, such as operations, regulatory requirements, or budgetary requirements. Lastly, accounts will also help you reduce the blast radius and help you with isolation. For example, a potential bug in one account is contained within the account and cannot impact the others. And also, these constraints will essentially help you store sensitive data in one single place. I've seen in various scenarios where the customers want as few accounts as possible, and in some scenarios, as many as possible. Again, there's not a right or wrong answer to that. So essentially, it depends on your business layout. The next decision that you want to make is, what account should I create? There are primarily like two categories based on the functionality. One is the core accounts, where you essentially have core functionality, and the other one is the workload accounts, where you have actual workloads running. So in terms of core accounts, you could have an organizations account where you can essentially do policy management and billing. You can have security account for consolidating the security controls or security tooling. You can have a log archival account where you essentially bring all the logs together in single location and for visibility. You could have a network services account where you essentially host all your network services. And you have shared VPC or shared services account where you have different services such as Active Directory, patch management, and other tools. And then you have sandbox accounts for testing that you can have. So these would be some of your core accounts. So when it comes to workload accounts, the questions that we need to answer here are, does each workload get its own account? Does each application workload get its own account? Does each business unit get its own account? Or does each environment such as dev, test, and prod get its own account? Does each regional workload get its own account? And does each team will get its own account and burner accounts? So to answer some of these questions, essentially, these are the things that can help you decide on how many accounts do you need and what accounts do you need. And some of them would be looking at the AWS service soft limits and hard limits, or the API rate limits. It could be the management overhead with too many accounts and the network complexity that comes with too many accounts. It's the cost overhead and the level of automation that is needed, and also the ability to maintain consistency and also maintaining operations across multiple accounts. To give you a quick real customer example, one of my customers essentially decided to use one account for each app and its environment. This was a great idea for isolation, but the management overhead became painful very quickly. Like, we had to do separate federation, additional maintenance was the biggest pain point, and the biggest one overall was the networking cost essentially came down to be more than the cost of the workload. So essentially, we had to go back, take a look at it, and simplify the number of accounts and reduce the number of accounts in this particular case. So again, as a result, what accounts should I create? So as a result of multiple workload accounts that are purpose-built to fit your business needs, essentially. So sandbox accounts, you could have sandbox accounts, pre-prod, prod, dev, which are pretty straightforward. Then you have your burner accounts that you want to use for experimentation. Then you can have your team-based accounts that are workloads that you can share within a team. You can have an application-specific accounts. You can have shared common application accounts and accounts that can go across multiple business units. So now that you figured out how many accounts you need, and if you're wondering how to create all of these accounts, then there are a couple of ways to go by. If you want to build this functionality from scratch with custom guardrails, and you can build it as a custom landing zone from scratch. Or the other option is you can leverage AWS service known as AWS Control Tower that can help you with providing automated setup of a secure and well-architected environment. Now, I would recommend that you take a look at the AWS Control Tower as it makes it a lot more easier to get started. So bringing it all together, you can use AWS services such as AWS organizations, where you have multiple OUs, and OUs are a construct where you can group accounts together so that you can apply something called as a service control policies that will help you with better governance. So this is a sample of one of my recent customer engagements where we were building an account structure based on the parameters provided by the customer. It was a multi-day engagement when we took time to understand the isolation boundaries, the business boundaries, the shared applications, the services, the workloads, and then the final product was something that they can fit in with today's needs and still set a standard and leave room for future growth, making it more robust. So the way that it looked like is we had a top level management account, and then we had accounts grouped by core application, core OUs, which is the core functionality. Then we grouped application specific accounts in one. Then we had different services grouped together. We created a bunch of sandbox accounts. And then there were accounts that were very specific to business units or different business units. And then we had accounts that were grouped by shared business units where we had different market segments that the customer was servicing. So this was at a very high level on how that account structure looked like. And we also created a policy staging environment because we didn't want to make any changes in the production, so that we can apply the policies on these test accounts first before they can be applied widely. So let's jump into the next step, which is the networking decisions. Since networking is an underlying fabric on which everything is built, it warrants for a very careful consideration. Some of these decisions in the networking are one-way doors. If you remember the one-way door and two-way door decisions, networking is one of the one-way door decisions in a lot of different ways. Things like CIDR block overlap, traffic control routing, these things essentially need very careful consideration. So you want to make decisions around, you need to decide whether you want to use a VPN connection or you want to use a direct connect as a dedicated link to AWS. Multi-account networking is an important component as well because accounts will be your ultimate boundaries. So here is where you decide whether you want to share resources across multiple accounts using services like AWS Resource Access Manager. This will help you avoid duplication of provisioned resources. Similarly, there are patterns to connect multiple regions to your data centers and region to region together using different services like Transit Gateway and Direct Connect Gateway. So there is a lot of collateral and blog posts and white papers that are available along with prescriptive guidance on how to design this based on your networking needs. Similarly, you need to design for VPC to VPC connectivity, the DNS resolution in terms of how the forwarder is going to work and how the hybrid mode is going to look like. Designing for east-west, inbound, outbound, north-south, east-west traffic filtering, in whichever way you want to call it, is also a critical piece for the network design. Along the journey, you may also bring many different partner tools. If you're already used to running these partner tools like traditional firewalls, IDS, IPS devices, network security controls, then you can essentially bring in those vendor tools and essentially follow their best practices as recommended. Finally, you need to think about your external connectivity needs where you have a B2B, B2C, remote office connectivity, SaaS connectivity, and things like that. Those have to be addressed as well. So here is a 10,000-foot view of an architecture sample from one of my recent customer engagements. If you double click on this, there may be many finer details, but at a very high level, here is how it looked like. So the customer had 2 data centers and they wanted to connect to 2 different regions on the AWS side. We made a choice to pick up essentially direct connects as a dedicated link with a fallback VPN to reduce cost from these 2 different data centers. Once that gets into the AWS site, essentially it is connected through the DX gateway, which will take those connections to each of these regions. Once the connections hit the regions, there are AWS transit gateways that will help with cross-region connectivity, and then essentially connects to a bunch of different accounts. So the idea here is, remember that you will be in hybrid mode for a very, very long time, until at least the migrations are done. So it's important that this setup needs to be production grade. So that is very critical for your applications. So going into the details of security decisions, we need to remember that security is an ongoing process. Many customers already have some or most of the security controls applied in their data centers. Migrating into the cloud, you can bring same or similar controls, but in the cloud, you have an advantage of making security as automated as possible. The foremost thing that you want to decide is how you want to access these resources. Typically, it's done through AWS Identity and Access Management or federation with your existing IDP solution. Understanding the least privilege access model is super important, and also set up controls accordingly. Again, there is a bunch of prescriptive guidance that is available on this particular topic. Detection has to be enabled at all layers. Think of this as layers of onion, where anywhere that is from the edge of the network to the servers, to the applications, to the data, to the databases, everything has to be enabled in terms of detection. Similarly, protection needs to be applied at all layers as well. Based on what tools you have, what tools AWS offers, you can essentially pick and choose the different tool sets that essentially help you protect your infrastructure. Data protection, another important topic where you essentially want to make sure that you are protecting your data in transit and rest, where you need to decide on how to procure or manage things like certificates, encryption keys, who has access to them, and so on. AWS offers native integration to most of these services, making it super easy for you to adopt services such as certificate manager or key management service and so on. Incident response can be fairly automated when with AWS native and partner tooling. Compliance is also based on type of businesses that you are in and what kind of data that your apps are handling, and understand the scope and pick the right set of tools on the AWS side. And you also always want to reuse the existing tools that you already used to. So these might be partner tools. So the idea is to bring in the tools that you're already familiar with and make sure that these clouds, these partner tools are essentially robust enough to handle the nature of the cloud. So it is difficult to show all the tools and solutions in a sample architecture just in a few clicks. But again, the biggest takeaway is maintaining consistency and automate as much as possible using frameworks such as NIST or CIS benchmarks to make sure that you have good standards across the infrastructure. So many times we ignore the operations aspect of things during and after migrations. Operations processes and teams layout usually has a big impact on many aspects of the architecture, from anywhere from multi-accounts to multi-region networking and who supports it and how they support it. We will cover this in depth in the upcoming modules as well, or episodes as well. But again, the idea is I've worked with many large scale and small scale migrations, and most common thing that I see here is that the operations teams are usually not involved in the initial phases. So for example, I recently worked on a customer migration where we had separate teams for the same Windows and Linux operations for different business units. Each team had different processes, and with the initial architecture, the management tools and automation was built to essentially accommodate one of the op teams in mind. And when the second op teams got onboarded, we essentially had to redo multiple things like retooling, modifying CloudFormation templates, modify the alerting mechanism, so on, which essentially caused unwanted delays in the go live process. So it's important to include operations as you go through the migration journey. Also, data and analytics is one of the most common workloads that we see in any company today. So the account layout and architecture changes quite a bit when you think about a particular workload, for example, data and analytics workloads. So it really depends on who your data producers are, where the data is getting generated from, who are the data sources, whether it's internal or external and so on, where the data is stored, in which system, and who are the data consumers. How are they consuming the data, whether it's a reporting tool or is it an AI ML tool. And also you need to decide on what kind of transfer mechanisms and tools and methods are you going to use for the data. And also remember, when you move the data across, there are data transfer costs that are involved in the process. So again, this is a sample data lake pattern. If you look on the left-hand side, you have line of business producer accounts, and the right-hand side, you have line of business consumer accounts. And there is a centralized data lake account. So this is one of the simplest patterns. There could be multiple variations to this pattern as well. However, the gist of the slide is that when you have multiple accounts, you need to understand how the data is flowing, where is it stored, and this usually has a big impact on your overall account architecture. So finally, having consistency across environments is super critical as well. So what is the operating model? Who is responsible? How is it done? So you need to essentially make sure that there is some form of drift detection that is implemented at multiple different layers. This could be built via various different services, such as AWS Control Tower or AWS Account Factory, or CloudFormation templates, or Terraform templates, CI/CD pipelines, configuration management tools, and so on. The idea here is implementing infrastructure automation is very important to keep that everything consistent and keep it automated. So now that we have a landing zone set up, let's move forward in the journey and talk about migrating workloads. Now, if you remember, we performed a dependency mapping in the assessment phase of the journey. We will take that as the input, and we will essentially create something called as an application migration wave plan. So here, I'm going to introduce to you a concept of 7R methodology that we use within AWS. This is essentially built on the 5 R's that Gartner coined back in 2011. This will help us determine what path are we going to take for our applications to the migration. The first one essentially is relocate, where R for accelerated migrations, we can essentially move hundreds of applications in days. You simply quickly relocate applications to AWS based on services such as VMware or container-based technologies with very minimal effort and complexity. The second R stands for rehosting, which essentially talks about is the simplest form of lift and shift, where if you talk about lift and shift, often when you look at migrations, half or more of the customer environments are typically fall under this category. So we can typically be migrated leveraging some tools and automate the processes. Replatforming, some applications might require modifications to address specific challenges or provide such key benefits, such as like reducing costs or moving to managed services. So that is where you essentially think about replatforming your services. Repurchasing, a lot of our customers are moving towards SaaS-based model today, and they're leveraging services such as Workday, Drupal, or Salesforce. Refactoring, in some cases, you may want to completely reimagine your application architecture and skip right to the state of art by leveraging broadest set of container-based, serverless-based, or managed NoSQL-based offerings that are available in the market. The rest of the 2 R's, retire and retain, essentially is that there might be things that may never move into the cloud, or maybe things that you don't want that can simply be shut off. So from the cost, time, and value perspective, relocation and rehost are the fastest and the cheapest. Replatforming and refactoring take a long time, but has a higher long-term value. So again, I've seen and experienced this. When you think about cloud, you automatically want to jump into refactoring mode to explore the full strength of the cloud. But this often leads to analysis paralysis and really long migration cycles. And after seeing many large-scale migrations, I would recommend you think about the rehost approach as much as possible so that you can get a quick business win. And of course, there will always be some net new applications such as AI/ML or HPC workloads that will automatically fall under some amount of refactoring anyway. So when it comes to tooling, choosing the right tool to migrate also determines your migration speed and success. So there are different categories of tools that we can view them as. In terms of server migration, there are tools such as Cloud Endure or Application Migration Service, Server Migration Service, VMware on AWS. In terms of categories, the second category would be a database migration tool, where we have tools such as AWS Database Migration Service, DMS, or Schema Conversion Tool, SCT. And for data migration, if you're looking for to transfer the data over the wire, you can take a look at services such as Data Sync and Storage Gateway. And if you're looking to transfer data in an offline manner, then you can leverage services such as Snowball devices. And for many legacy applications, there are migrations tools such as App to Container, where essentially we take your application and convert them into containers. Or there's also an option for end of support migration program for Windows Server, in short, which we refer to as EMP, which will essentially help you with the legacy applications. So again, in the process, there are many partner tools that can help you throughout your migration journey. So now that we understand the migration methodologies, let's quickly walk through the 2 most popular paths that our customers take. And these are the other ones are fairly important as well, but they appear on as needed case by case basis. So the first part we usually see is referred to as rehost and relocate, which is lift and shift. So this is the fastest, as we talked about, and the easiest way to bring things into the cloud. This is a true lift and shift of virtual machines and data into the cloud. So this is where we need to pick a migration tool based on the workload that is need to be migrated. At this stage, I've seen some customers get hung up on the idea that lift and shift is a bad idea. But that is not entirely true. So often this will always include slight refactoring anyway. If you think about it, things such as leveraging native AWS functionality such as load balancers, implementing auto scaling, traffic routing, DNS, etc. All these things will essentially fall under a certain amount of refactoring. So this will eventually give you the runway or pave a path for refactoring in the cloud. So if you've heard of this expression before, don't change too many things at the same time, then this is probably the best path to take. The next path that we see is replatforming or refactoring methodology, which essentially requires much longer cycles. These typically end up being a deep dive workshops where you take a current architecture and map that to an equivalent architecture on the AWS platform. This could be a radically different approach, like moving into containerization or serverless platforms. The most common deep dive approaches that I've seen work with customers is maybe a questionnaire-based model, or maybe a multi-day, multi-hour workshop engagements, whiteboarding sessions, or even using blog posts and white papers, or using AWS prescriptive guidance that is available to you for many different workloads. So from the output point of view, you essentially, out of this, we're going to get a migration plan. So now that we have a landing zone that is ready to migrate, and migration plans are also ready, so this is where we begin to migrate. To test what we built in the previous steps and validate our approach, we always want to pick 3 to 5 different applications and begin and run them through the cycles of dev, test, UAT environments. Always run a well-architected review at that particular stage before you cut over into production. And if you choose agile methodology for your migrations, you can treat each of these migrations as sprints and each stage in that as a wave, as a story, right? So the idea is essentially pick 2 to 5 applications and run and test your processes. So once you gain confidence in your approach and you essentially address the remaining gaps through these applications, it is time to start to rinse and repeat the process, and we can essentially migrate the rest of the applications. Now, after you moved majority of your applications into the cloud, we need to start planning for the next steps, out of which data center decommissioning might probably be the first. So just like when you build a data center layer by layer, we need to take the reverse approach of stripping out these layers. Example, applications are going to move out first, then the supporting infrastructure, such as Active Directory, DNS, and then the networking gear, and then dismantling drives, followed by servers, and followed by racks, and so on. So this could be a long effort. It could essentially span multiple months. So based on the size, make sure that you plan well ahead of time if you have a hard data center exit date. So now that you're in the new world of the cloud, we need to start establishing operating frameworks and tools for the management. Game days is something that I recommend to test your resiliency and your production readiness. And you also want to complete the establishing the ITIL integrations for your workloads inside AWS. Now, always remember to conduct an ongoing well-architected review for individual applications, as the applications also are going to go through multiple different changes. And cost optimization to keep things in control, which again, most organizations do it really well, but sometimes it might get off track very easily. So remember, again, you're not alone in this journey. We do have 80 plus migration competency partners that we have established migration practices with. And these are AWS certified consultants that you can leverage for your migrations. We also make sure that we audit these consultants are actually audited annually against their competencies to provide you with the best experience. All right, so finally we reached the end of the migration journey. So now that you're in the cloud, there is always room for more optimization, modernization, and innovation with cloud native services. Finally, if you don't remember everything that we covered in this session, I want you to walk away with these 5 things. 1 is business and people alignment is a necessary ingredient for migration success. 2, Avoid analysis paralysis. Don't let the complexity of migrations discourage you from moving forward. We have proven methodologies that can essentially help you through the process. Migration readiness or migration readiness assessment or MRA workshop is a mandatory exercise even if you're already operating in the cloud today. Infrastructure planning and setup. This is well worth spending time upfront to create a robust landing zone that essentially suits your business and essentially create. So the idea is you want to avoid an AWS to AWS migration in a couple of years because you want to implement a robust way of implementing your infrastructure. And finally, leverage AWS and partner network. Again, there are no brownie points for reinventing the wheel here. So always think about in terms of leveraging the existing collective knowledge to accelerate your migrations and also reduce risk. So remember that this is only the first of the 6 episodes under deep dive into designing a successful migration journey. So we look forward to seeing you on the next episodes. Thank you.